Hi, I'm KB. I've had requests to do a AquaComputer AquaSuite beginner's guide or startup tutorial, so here it is. This is part 1 of a series. In this part, I'll talk about the hardware I believe is needed and do a walkthrough of the different devices. I will not talk about how to choose pumps, radiators, water blocks, tubes, or how to plan and build the loop. There are other sources out there far better qualified than me to help that. Here, I will solely concentrate on controlling and monitoring the loop with an AquaComputer controller. And for that, you will of course need a controller. I recommend a Quadro, like the one I have here, or an Octo, depending on your needs. We'll look into the differences later. Beside that, I believe that a water temperature sensor is essential. When you know the water temperature, you can much better determine the radiator fan speed needed. Some people will say that you can control the fan speed by the CPU and GPU temperature or load, but you quickly run into some difficulties if you have two heat sources in one loop. And since the radiator and the fans cools the water, which in turn then cools the devices, you're trying to control the temperature 2 steps down the heat transfer chain, which can lead to the controller overcompensating the cooling power needed, and therefore fluctuating power levels to the fans. And it's quite annoying to listen to fans going up and down in speed. And if you don't measure the water temperature directly, you really don't know how hot the water is. And depending on your choice of tubing material and the water pump's temperature operating range, you could, without knowing, exceed some critical temperature limit for those. And for that reason, you'd have to err on the cautious side and run the fans faster than is actually needed, which leads to increased noise. So the bottom line, get a water temperature sensor. For the sensor, you have some different options. I have two of the most common types here. Let's take a closer look at these. Here we have the two types of temperature sensors. This one is a ring type, where the water flows through the sensor. It can be placed virtually anywhere in the loop. This model has a male thread on one side and a female thread on the other side. You can, for instance, mount it in a fitting and attach both to a radiator. These are very easy to fit into the loop. The other type is more of a probe-shaped kind of model. It has the temperature sensor out here in the tip. This kind is mounted in an unused port, like in this reservoir. Just make sure it touches the water. It could also be a port in a radiator or a spare port in the pump housing. So where should you place the sensor? With the probe type, you might only have a few options. But as I said, this ring type can fit in everywhere. If you're using a fan curve to control the fan speed, it doesn't really matter where you place the sensor in the loop, since the water temperature only varies a few degrees around the loop. But if you're using a target temperature fan controller, I'll recommend that you put the sensor right after the outlet of the radiator. Since the fans control the cooling effect in the radiator, you'll get the most stable control of the fan speed that way. Water cooling temperature sensors are pretty standardized, so it doesn't really matter which brand you use. They are all built around a 10 kilo-ohm thermistor. You only have to watch out that you get one with the correct connector. The Quadro controller uses a 2-pin DuPont connector. They are relatively cheap. You can get a good sensor for around 10 euros. You can also get other devices that have a temperature sensor integrated, like a water flow meter or pump. In that case, they typically have an USB interface and are connected to the motherboard. The disadvantage of not having a temperature sensor connected directly to the controller is that there can be some latency before the measurements reach the controller, and that can make a target temperature controller a little unstable. You are also dependent on some software or service that has to be running on the computer to make the controller able to retrieve the readings. Let's take a look at what comes in the box. A quick start guide. It's a good idea to read this. It also has information on the AquaSuite software. Then we have a USB cable. We get a temperature sensor, of course, with the right connector. This can, for instance, be used to measure the air temperature inside the computer case, which is useful if you're using the controller to control fans that handle the case airflow. Or if you don't have a proper water temperature sensor, you can tape it to the metal part of the radiator to get a reasonably good measurement of the water temperature. Just make sure to keep it away from any airflow. We get some nuts and bolts to mount the controller. And finally, the controller itself. Quite a neat little device. The rubber back can be peeled off. And the front plate is removable as well. Then it can be fastened inside the computer case with the supplied bolts if you want to secure it that way. You can also use some double adhesive tape or jam it in somewhere. Just make sure that the exposed connectors don't touch any metal part of the case. Let's take a look at the connectors on the controller. At the top, we have a power connector. It's a standard 4-pin Molex connector. Then we have 4 connectors for fans and other PWM devices. That is 4 individual channels. It is important to use 4-pin PWM fans, like this one I've got here. It has a matching 4-pin connector. If you need more than 4 fans, you can use splitters. I have a splitter here, which splits out to 2 connectors. That way you can put more than 1 fan per channel. You can get splitters with 3, 4 or more connectors. And you can change splitters as well to match the required number of fans. However, be aware that a maximum of 2 amps can be drawn per channel. Just check your fans and make sure you don't overload the controller. This fan uses 0.11 amps at full speed, so you can have a reasonably number of fans on each channel. Just remember that all fans on a channel will run at the same speed, so group your fans with that in mind. It is important that you use PWM fans. I have an old fan here, which has a 3-pin connector. They don't work as they will constantly run at 100%. The fan connectors can also be used to control the speed of a PWM pump. However, be aware that the pump doesn't draw more than 2 amps. Some pumps do use more than 2 amps at full pressure. But typically there are 2 connectors on a PWM pump, so you get one PWM connector to control the speed and another connector where the pump gets the power from, typically a 4-pin Molex or a SATA connector. To the right, we have a number of special connectors. We have a connector for a flow sensor, which can be used if you have a flow sensor that emits pulse signals in the old-fashioned way. Many newer flow sensors are connected via USB directly to the motherboard. If you connect a flow sensor directly to the controller here, you have to be aware that it must have a Molex PicoBlade connector, or you'll have to get an adapter cable. Then we have an AquaBus connection. Quadro and Octo controllers can only act as clients on an AquaBus connection. At present, only the old AquaAero controllers can act as masters, so this is maybe not so useful in practice. We have a RGB connector here, where RGB strips with individually addressable LEDs can be connected. Up to 90 LEDs can be controlled on this connection. At the bottom, we have 4 connectors for temperature sensors. If I use one of the water temperature sensors from before, you can see that it fits well here. And finally, we have a USB connection, which fits the supplied USB cable. At the other end, we have a flat USB connector. Typically, there are internal USB connectors on the motherboard with 2 USB channels on each connector. Now, this is just a USB hub, but the connectors are the same as the ones you will find on the motherboard. So 2 USB connectors can be plugged in here. The 2 black wires are the ground connection. And if we look closely at the connectors on the motherboard, we can see that a pin is missing at one of the ends. And the side where the pin is missing is the side where the ground connections go. So we can put it in here. And it doesn't matter if you choose the top or bottom row. So you can put 2 AquaComputer devices into one motherboard connector. A Quadro is currently available for around 50 euros. Its big brother is called Octo and costs about 75 euros. And what do you get for the additional 25 euros? My Octo controller is mounted in my computer, so unfortunately I cannot show it. But I have the next best thing here, a printed Octo. If we look at the differences, then we have 8 fan channels on the Octo, so 4 more than on the Quadro. In addition, there are 2 RGB channels, where we only had one on the Quadro, so 1 times 90 LEDs and 2 times 90 LEDs on the Octo. And the Octo has a signal output connection. It can be used to send a signal to the power button connector on the motherboard, so you can simulate a physical press of the power button if an alarm occurs in the Octo. That way, the computer can automatically be shut down in a fairly controlled manner if, for instance, the water stops flowing or the temperature rises above a set limit. That is extremely useful, but be aware that you have to buy the cable if you want to use this feature, and that is an additional 4 euros. In the next part of this series, I'll go into doing a basic configuration in AquaSuite. And as always, questions and comments are welcome below. And please remember to like and subscribe. Until next time, be happy and have fun.